Download this code from codegive.com, link in the description below. Sure. Query processing and optimization are crucial components of database management systems, dbms. They ensure that queries are executed efficiently and return results in a timely manner. Below, I will provide an informative overview of query processing and optimization, along with a code example. Query processing. Query processing refers to the series of steps that a DBMS takes to execute a query. It typically involves the following stages. 1. Parsing. The query is parsed to check for syntax errors. The query is translated into a parse tree. 2. Translation. The parse tree is converted into a relational algebra expression or an internal representation that the DBMS can understand. 3. Optimization. This is the most critical step, where the DBMS generates one or more execution plans and selects the most efficient one. 4. Execution. The chosen execution plan is executed to retrieve the results. Example of query processing. Let's consider a simple SQL query. Step 1. Parsing. During the parsing stage, the DBMS checks the syntax and builds a parse tree. In pseudocode, it might look like. Step 2. Translation. The parse tree is translated into a relational algebra expression. For this example, the translation might yield something like this. Step 3. Optimization. During the optimization phase, the DBMS evaluates different execution plans based on cost estimation. It might consider factors like the size of the tables, indexes available, the cost of different join operations. Pseudocode for an optimizer might look like this. Step 4. Execution. Finally, the execution plan is executed to retrieve the results. In a real-world scenario, this would involve interacting with the database engine, but here's a simplified version. Query optimization techniques. 1. Selectivity. Choose the most selective predicates first to reduce the number of rows as early as possible. 2. Join optimization. Use different join algorithms, nested loop, hash join, merge join, based on the size of the data sets and availability of indexes. 3. Indexing. Create indexes on columns frequently used in where clauses to speed up lookups. 4. Query rewriting. Transform the query into an equivalent one that is more efficient, such as using exists instead of in. 5. Cost-based optimization. Use statistical information about the data to estimate the cost of different execution plans. Conclusion. Query processing and optimization are essential for the performance of database systems. By understanding the stages of query processing and employing various optimization techniques, you can significantly improve the efficiency of your database queries. In real-world applications, the DBMS handles all these steps internally, allowing developers to focus on writing queries rather than optimizing them manually. However, understanding these concepts is crucial for troubleshooting performance issues and designing efficient databases.